through this. Here we go. This is finishing up from yesterday using that exponential equation. This one. CE to the KT. That was the problem we finished with yesterday, right? That was just the problem. But this is the general formula. That's the general formula. The one we did yesterday with the N was just for that particular example. Oh, okay, sorry. All right, so here we go. This example says find the exponential function. And folks, I'm going to go through this very fast, that passes through the given point. Those would be your instructions. Your first example, pretty easy, and Hector's already pointed out, that's going to look like number such and such. This problem might look a lot like another problem you may have to do for homework tonight. We're going to find the exponential function that passes through 0, 1/2, and 5, 5. And if you remember the exponential function, 0, 1/2 would, I don't know, if that's 1, doesn't the exponential function do something like this? Okay. So clearly, is that going to be, just for kicks, is that exponential growth or exponential decay? Decay, growth, isn't it? Did I just say? Okay, growth. Why? It's increasing, okay? Now, it is also a translated exponential function. Why? It doesn't pass through what number? It doesn't pass through this one right here. 1, 0, 1. Why does it have to pass through 0, 1? The parent graph for e to the x. For your exponent, what do you get? 1 every single time. Just saying. All right, so here we go. What are we going to do with this? We are going to do the same thing we did yesterday using that formula. And if you remember, this is like the variation problems from Algebra 2. So, y equals c e to the kt. The first order pair we're going to work with is 0, 1/2. You plug in what you know. I know that 1/2 is y. C e to the k times, yep. So 1/2 is equal to c times e to the who, which is 1, isn't it? So 1/2 is c. Haven't we done a problem with this already today? Okay. Now what? Plug it into the next one. Okay. I'm going to have 1/2 as c, but I'm also going to have a new ordered pair 5, 5, right? Okay. So the second part of this problem. Same formula. Five is equal to 1/2 e to the k times e. All right. Now, let's think about what's going to happen. 1/2 e to the 5k. What are we going to do? What do we have to solve for? I've got to solve for k. If I divide by 1/2, multiply by its reciprocal, which is 2, what I do to one side, have to do to the other. They're going to cancel out, and I'm left with e to the 5k is equal to 10. Now what? How do I undo e? Natural log, and I do that to one side. I have to do it to both sides. And what is the natural log of e to the 5k power? The 5k is equal to natural log of 10. What now? Don't ask me why I did that. Is it 1/5? You could write 1/5 ln 10, but if you think of that as the natural log of 10 is its own number, and I cannot reduce this value right here with this 5. Okay? I can't. If the 10 would have been in the front, could I have reduced then? Yes. I don't care what version you use. I personally like, believe it or not, this one for this purpose, I think. Now what do? I just told you another lie. Say it again. Plug it back in where, holy moly? The formula again. So that's second part. Here's third part. Well, we want to use our C value, which was what? 1/2 E. I told y'all a lie. Oh, I hear you. Oh, it's all right. It's all good. What now? Put K. So it's going to be K to the K to the that right there times T. Yes. So what?
Whenever you're multiplying the number to the natural log of something, that number that you're multiplying by becomes the
No. We're done for all practical purposes with this problem. The only difference that you could have here would be if you were if you were to go back and write K as one fraction. That would be the only other option that you could have if, pardon, that just because I had it down there and I erased it and y'all went, oh, and now I'm reintroducing it as an acceptable. I need sleep. I need sleep. No, I've not had my juice today. The 0 for the T, because 0 was just part of that one ordered pair. This is the function, because remember your ordered pair is going to be T, Y, X, Y. So I could give you a set of data with a bunch of X points or T points, and I could plug that T value in here, and it would give us an output value. And plug another T value, and it would give you another Y. No, I just have to have the Y, and I have to have the T, okay, for my final equation. No, it really isn't. It really isn't. Okay, now, you may think differently on this next problem. Awesome. Aren't you glad you know that? I know. All right, here we go. Same thing. Create the exponential equation that goes through 3 1/2 and 4 5. Same formula. I'm sorry, what? No matter what you use, it's not going to work. okay? So here's what you do. We go through the same process as always. Use the first ordered pair and plug those in. How many more days? 14? 13 and a half. 13 and a half. Here we go. 1/2 is equal to, right on? Okay, keep going. Now what? Well, oh, that's kind of weird, right? All right, so let's go to the let's just stop here for a second, see what's going to happen. Go to your second ordered pair. So I'd have 5 is equal to C, E, bless you, to the K times 4. 5 is equal to C, E to the 4K. What now? Nothing canceled out, right? So, what do? These are the problems. When nothing cancels out, or when our E's don't cancel out, we got to figure out what to do. So here's what I'm thinking. I've got a 2 here, and I know it's in the denominator, and I've got a 5 here, right? What numbers does 2 and 5 have in common? 10, okay? Right? If I put them together, if I multiply them together, I'll get 10. Is everybody, yes. All right, so here's what I would do. How would I get, if I set them, I want them to equal, 10 is equal to C, E to the 3K. Skip a line in here, folks. Skip a line and then write 10 equals C, E to the 3K. And if I had 10 equals C, E to the 4K, why do you think I want them both to be equal to 10? So then I can set them equal to each other, and that will help me, okay? So now I'm kind of working backwards. I figured out I want them both to equal 10 because I had a 2, I had a 5, multiply to get 10. What number do I need to multiply to this equation here on the left? 1/2 times what gives you 10? 20, okay? And of course, if I multiply 20 to the left side, what do I have to do to the right side? I have to multiply 20 to the right side as well. Is that going to be okay if I change that next step? 10 equals what? I've got to change that to be 20C E to the 3K, don't I? Is that okay? What am I going to do over here on the right side? I'm going to multiply 5 by 2. And if I multiply 2 to the left side, I have to multiply 2 to the right side, which makes me have to go back here and change this. But now I'm getting somewhere, right? Now, they're both equal to 10. What do? Algebra, y'all, come on. Can I divide by 2? Divide by 2C, yep, you're right. They're going to cancel. What am I going to be left with on the left side? 10 E to the 3K equals what? E to the 4K. And at this point, you guys may have figured out what are we going to do to both sides. Well, natural log. How do I get out of the E? Take the natural log of both sides. And then what? Oh, hold up. Not yet. Can we hold off on that just a second? What did y'all say? All huff and puff. Divide by e to the 3k. Why? Yes, you can. And I'm going to get 10 is equal to e to the who? K power. Now it's worked down to where it's smaller and easier. So what am I going to do? Now, natural log of both sides. Oh, geez. Can I do anything to natural log of 10? No, I got to leave it alone. What's the natural log of e to the k? K. Holy moly. Am I done? Is that the equation? Remember, I need the equation. What do I not have? I don't have C. Oh, okay. I have K. Now let's find C. Here, first one. I don't know what Y is. Do I know what Y is? Yeah, we do. We can pick one. It makes it really easy. Yeah. Let's go with the 1/2. Okay. What was that order pair? 3 1/2. See, we're trying to find e to the natural log of 10 times 3. Is it the 10 that's being multiplied to the 3? No. I got to rewrite that. Is it that right there? Now what do I do, folks? What is e to the 3 ln? How can I write 3 times ln 10? That's what I'm, yeah. All right, that right there, folks, from here to here, that's using your ln rules, your exponential rules, okay? If you say ln 10 raised to the 3rd power, okay? Now the e and the natural log cancel, okay? Yeah, right there. So that's going to give me what? This right here is what's going to cancel. C times 10 to the 3rd power. What is 10 to the 3rd power? It's 1,000, isn't it? Okay. And folks, remember this is all done without a what? What's 1/2 divided by 1,000? It's a very 0.00. You know what though? That's what C is. On an AP exam, would the AP reader count it wrong if you left C as 1/2 divided by 1,000? No, because it's correct. Okay? Am I done yet? No, not yet. Now we got to find that final equation. Y is equal to, what's C? E, what's K? That right there's the answer, y'all. Oh, Lord have mercy. Okay. I'll email you these two other examples I want, and you've got to either write them in your notes or print them off and put them in your notes, okay? All right.